Hello friends, welcome you all. And in this lecture, we will discuss removal of left recursion from context-free grammar. Now, I will tell you what is left recursion and how do you identify left recursive grammar, and why do we need to remove this left recursion. So first is left recursion. As you can understand the recursion, if recursion is there in any function, so function calls itself. Now in grammar also there may be recursion. Both type of recursion may be there in grammar, left recursion and right recursion. So how do you identify grammar which is left recursive or right recursive? So recursive production are there, like if left hand side variable is also appearing in the right hand side, then the production is recursive production. Because suppose if I take one example, a gives a, that production we have used so many times. So now you can see here a gives a small a, capital A. That means a is defining itself. So this is recursive production. Now here you can see a is appearing in the right hand side at rightmost position. So this is right recursive production. This is right recursive production. So this is recursive production. Now what kind of recursion is there? So it is right recursive production. Right recursive production. Now suppose variable which is at left hand side of any production is appearing at the first position in the right hand side. So like this. So this is also possible. So now this is called left recursive production. Now each and every language is having its compiler. So in compiling process, sometimes this left recursion is not supported. So what we do, we convert it to right recursion. Or as the topic of this lecture is removal of left recursion from CFG, so it means we are converting left recursion into right recursion. If recursion is there in grammar, then we cannot remove this recursion, but we can simply convert recursion from left recursion to right recursion. So we will convert left recursion into right recursion. So now in this lecture, we will see the process of converting left recursive production into right recursive production. So I hope the type recursive production, what do you mean by recursive production, and why do we need to remove it? It would be very much clear. Now I will take one example and I will tell you the production where we can convert left recursion into right recursion. Now I will tell you the way to convert left recursion into right recursion. So while we are converting left recursion into right recursion, then we sometime we need to add one additional variable in the grammar. And if we are adding some variable in the grammar, obviously we need to add some production of that variable. So I will tell you how do we convert left recursion into right recursion. So process is, suppose there are two types of production in the grammar. There will be some production left recursive and there will be some production which are not recursive production. Suppose there are some production of some grammar are like this. A gives A alpha, which are left recursive production. And there are some production of A again, which are non-recursive production. So we can consider them as A gives beta. Now we are having these two type of production, left recursive production and a non-recursive production. So now we need to convert this particular recursion into right recursion. So now how to convert this left recursion into right recursion? So we will see, we will add one more variable here and we will also add the production of that particular variable. So now how we are deciding the variable. See, the variable name, you can have anything. Now here, to explain this process properly, I am adding one additional variable here, a dash, because I am removing the left recursion of variable a, so I am adding one variable a dash. So now here, how we can convert this left recursion into right recursion using a dash. So you can write it like this: a gives beta a dash, a gives beta a dash, and a dash gives alpha a dash, and one more production we will add here: a dash gives epsilon. These are the type of production. These are all left recursive production will come in this category, and all non-recursive productions will come in this category. Now we can rewrite the formula, you can say the formula, in one more different way. So now suppose you have more than one left recursive production. So like this: a gives a alpha 1, then a gives a alpha 2, and like this you have a gives a alpha n number of productions you have for which are left recursive, and non-recursive productions you have: a gives beta 1, beta 2, up to beta m, like this. So you have how many productions you have in the original grammar? N number of productions which are left recursive production, and m number of productions which are non-recursive production. So now how to convert these left recursive productions into right recursive productions? So as I told you, I can take a dash again here. So a dash, sorry, first we will write this particular type. So a gives beta 1 a dash, beta 2 a dash. Similarly, we can have beta m a dash. Now we will rewrite all these left recursive production in the form of right recursion. So we can write a dash gives alpha 1 a dash, alpha 2 a dash, up to alpha n a dash, and one more production with epsilon here. So epsilon will always be there with a dash. So this is the different way of writing the same formula here again. So if you are having multiple left recursive productions, multiple non-recursive productions for particular variable, then you can use this representation for this. So now I will take one example here, and I will show you how to convert left recursive production into right recursive. Now I am taking one grammar as example here. So which is E gives E plus T or T. T gives T cross F and F. F gives ID. So now you need to know. So we will target one production, one variable at a time. So now we consider the variable E here. So first we will convert all production of E in right recursive productions. So see, you can see there are there is one production of E which is left recursive. So E gives E plus T, and T gives T cross F. This is also left recursive production. So now we consider first all productions of E. So we are having E gives E plus T, T or T. So now you can identify here. There is one production which is non-left recursive, and one production which is non-recursive production. So E gives E plus T is left recursive production, and E gives T is right non-recursive production. So here for left recursive productions we have alpha. So with this you need to identify the alpha properly. Now A gives E alpha. That means E gives E, and whatever after E is there, this is alpha. So we can consider this as A gives A alpha. Now A gives A alpha. So alpha here is plus T. Alpha here is plus T. And we can consider A gives beta, which is non-recursive production. A gives beta. So beta here is T. Beta here is T only. And now you can write it like this. Now, if I convert these left recursive production into right recursive one, so how we would be doing? So we will add one more variable here. So as we are converting all productions of E in right recursive productions, so simply I can use E dash here, E dash, right? And now the production of E will be how? A gives beta A dash. So here we are considering new variable as E dash. So E gives beta E dash. So beta is T. So E gives T E dash. Now there is only one beta. So I will write only one production of E here. Now A dash, the variable which we are adding to the grammar. So we will write its production now. So here we are adding E dash. So now we will write production of E dash as E dash gives alpha E dash. So E dash gives alpha. Alpha is plus T E dash. And there is only one alpha. So only one production will be there like this. Now one more production will be there. E dash gives epsilon. Now after removal of left recursion from for variable E, we have two productions as E gives T E dash gives plus T E dash and epsilon. Now we will consider the production of T. So T gives T cross F or F. Now again we are having A gives A alpha and A gives beta. So only one alpha is there, only one beta is there. So now we can simply write, we will use now T dash as new variable. So we can now write T gives beta T dash. Beta means F T dash. Now there is only one beta, so we will have only one production of T here. Now T dash. T dash gives alpha T dash. Alpha means asterisk F. So asterisk FT dash. And there is only one alpha, so we will have only one production there along with epsilon. T dash gives epsilon. So this is how we have converted left recursion of T in right recursion. So now we have three more production here. T gives FT dash. T dash gives asterisk FT dash epsilon. Asterisk FT dash epsilon. Now third, we consider third variable. So in third variable F, we have only non-recursive production. So no need to change anything. So we can directly write F gives ID here. F gives ID. So after this is our left recursive grammar. This is our left recursive grammar. And after removing left recursion or after converting left recursion into right recursion, we got this particular grammar. So now here we had five productions. Here we had five productions. Now here in this grammar we have 1, 2, 3, 4, 5, 6, 7 productions. We have seven productions. In this original grammar we had only three variables. Here now we have five different variables. So when you convert left recursive grammar into right recursive grammar, so number of variables are increased and number of productions are also increased. So I hope the process is very much clear to all of you now. So now I will take one more example where we have more than one alpha or beta. So now this is one more example where we have more than one alpha and more than one beta. So now the only important thing to identify alpha and beta carefully. So you need to identify all alphas and you need to identify all betas. So here in this particular grammar, we have two variables E and T, and some terminals we have plus asterisk A and B. Now we will convert left recursive productions of this grammar into right recursive one. So now we target, see, we have in this particular example, we have only one variable which is having a left recursive productions. So we will take it. So now how many productions we are having for E? Four productions we are having there. So now two productions are left recursive productions and two productions are non-recursive productions. So now all the left recursive productions we can consider as A alpha, as A gives A alpha. So now A gives A alpha, that is, this is alpha 1. Now A gives A alpha. So again we have this alpha 2. So now you can consider the second representation of formula. A gives A alpha 1, A gives A alpha 2, like this. Now here E gives A and E gives B. So these are non-recursive productions. So we have A gives beta 1, A gives beta 2. So I can write this as beta 1 and beta 2. Now you can have any number of alphas here. You can have any number of betas here, like this. So now we will try to convert all these productions into right recursive one. So we will add one more variable here as E dash again. E dash again. Now if I'm using E dash here, so first I will write the production of E. So how do I write production of E? So for production of A gives beta A dash. So how many betas are there? Two betas are there. So I will write beta 1, that means small a, E dash, and small b, E dash. So beta 1 A dash and beta 2 A dash. Now I will write production of E dash as alpha 1 A dash. So alpha 1 is plus T E dash, and alpha 2 A dash, that means asterisk T E dash. And we always add one more additional production as E dash gives epsilon. The variable which is we are adding to the grammar, we create one production, epsilon production of that particular variable. So I have written here E dash gives epsilon. Now we have completed all production of E. Now T is having only non-recursive production, so we need not to do anything with production of T. So this is the final grammar after removing left recursion or after converting left recursion into right recursion. So I hope, friend, it would be very much clear now. So if you have any doubt, you can always write to me in comments and I will definitely reply your comments. Thank you so much.